In trigonometry, we'll start with the angles, the one that we call special angles. These are very, very important in trigonometry. You need to know them. So I'll categorize the angles into two. Okay, the first category will have angles 30, angles 45, and 60. These angles, for 45, you use a triangle. Okay, use a triangle. 45, 45, 90. Okay, so here you have one, here you have one, then you add 1 plus 1, because you're doing 1 squared plus 1 squared, you get 2, and then its square root makes the hypotenuse. And you know that when you say sine 45 from SOHCAHTOA, when you say sine 45, you are talking of opposite, which is 1 over hypotenuse. If you want, you can rationalize this so that you write it as root 2 over 2. Okay, when we say cos 45, same thing, 1 over root 2, which you can write as root 2 over 2. When you say tan 45, tan from SOHCAHTOA is opposite over adjacent, so you get 1 over 1, which is 1. Or if you know these first three, if you know sine, cos, and tan, then surely you know cosec, because cosec is just 1 over sine. Then surely you know sec, because sec is just 1 over cos. Then surely you know cot, because cot is just 1 over tan. That is basic. Okay. Second is 30 and 65. So you say this one, you use a triangle again. Which triangle? The one which has the angle 30 here, and the angle 60 here, and this is 90. So you have 1 this side, okay, you have 2 this side, and so if you do 2 squared minus 1 squared, and then get the square root, you have the root of 4 minus 1, which is root 3. So this is root 3. Again, from SOHCAHTOA, we can get sine 30 as opposite, which is 1, because opposite of 30 is this one, over hypotenuse, which is 2. You can get sine 60. Sine 60 is opposite, which is root 3, over hypotenuse, which is 2. You can get, now we go to cos 30, adjacent, which is root 3, over hypotenuse, which is 2. You can go to 60, adjacent, which is 1, hypotenuse, which is 2. You can go to tan, tan 30, which is root 3 over, tan 30 is opposite over hypotenuse, opposite over adjacent. So opposite is 1, adjacent is root 3. So you can go to tan 30, again opposite over adjacent, so that will be root 3 over 1, which is just root 3. Again, if you know this, then you know cosec, you know sec, you know cot. Then now we go to second category. Second category of special angles, the ones I call the big 5. The big 5, okay? The big 5 angles. Which ones are those? So I'll put them on the X or Y plane. Well, to start with, we know that Y is 0 on the Y axis, on the X axis. So if I say X is 1, then Y will be 0. If I go to the Y axis, X will be 0, Y will be 1. This side, X will be -1, Y will be 0. This side, this will be 0, this will be -1. And on the quadrants, we have angles 0, 90, 180, 270, 367. So you have sine 0. So if you pick them now as coordinates, when you bring the functions, so it will be sine this is cos sine. That's how the coordinates are sitting. Cos sine. Cos sine. Okay. Cos sine. What does that mean? That means that cos 0 is equal to 1. Cos 360 is equal to 1. Okay. Cos 90 is equal to 0. There, where there is cos 90, you get 0. Cos 180, -1. Okay. And cos 270, that is 0. You bring down sine, so we have sine 0, and that is 0 there. Sine 360, and that is 0. Sine 90, we get 1. Sine 180, we get 0. And sine 270, we get -1. Well, and then for the big 5, you just need sine and cos, because you realize that tan is actually sine over cos. So you can easily get it. Okay, you know sec is 1 over cos. You know cosec is 1 over sine. So those are easy tasks for someone to do. So you need to know these angles. Now, because you won't only be dealing with these angles, there are times when they'll give you angles like 120. Okay, angles like 150, angles like 210, or which we haven't talked about here. So what do? Say, okay, if I face such a situation, then I'll say, okay, I'm going to deal with the quadrants now. I'm going to deal with the quadrants now. The quadrants, we know we have 4 quadrants. Okay, we have 4 quadrants. In the 4 quadrants, the first thing to start with is that all the trig are positive in this one. And here, only sine and cosec are positives. Here, only tan and cot are positive. Here, only cos and sec are positives. The ones I haven't written in this quadrant, they are negatives. That's the first thing. The second thing is that, well, we also have the issue of reference angles. So let X be a reference angle. And if you are given an angle in the first quadrant, they give you an angle, and that is between 0, which is theta, and between 90. We know the boundary is 0 90, 180, 270, 360. So you say, okay, if I'm given an angle between 0 and 90, and they ask for a reference angle, they want to get x, then it will just be equal to that same angle that I'm given. Okay, in the second quadrant, they want x, and you're told theta is between 90, less than theta, and less than 180. And they want a reference angle. Remember, x is the reference angle. So they want a reference angle. So you'll say 180 minus that theta given. If theta is between 180 and 270, and they want a reference angle, you say theta minus 180. Okay. If theta is between 270 and 360, and they want x, the reference angle, you say 360 minus theta. This is how you get reference angles. So if they give me angles like 110, angles like 150, I will just check which quadrant that angle is found, and then look for reference angle. Take note that when they say sine x is positive half, for example, you are interested in the sign, it is plus. And we have said sine is plus in two quadrants, in the first and second quadrants. This will give two solutions. Okay, that is for the interval 0, less or equal to x, less or equal to 360. Because of that plus. If they said sine x is equal to minus half, this will give two solutions. Why? Because sine is negative in two quadrants, in the third and in the fourth quadrant. And what happens when you're dealing with a small angle? Okay, dealing with a small angle, because this one, you always ignore the negative first, find the angle that is x that will give you half, and then start using that angle to get angles from the quadrants. So now if x, if 0 is less than x, which is less than 90, or maybe let me be specific this time around. If x is equal to 30, 45, or 60, these are the three most respected reference angles. Yes?
So I was asking if you can just explain the part where sine became negative half.
Oh, okay. That's what a bit. If x is 30, 60, or 45, then they want you to find the angles that are related to x in the second, third, and fourth quadrant. When you come here, you say theta is equal to 180 minus x. In the third quadrant, theta is equal to, so Yeah, I need to change. Okay, yeah. So it is 180 plus x. Then here theta is equal to 360 minus x. So look at where x is. If you have these three angles as your x values, I get back to the example now. For example, solve the equations now. Solve the equation A sine x is equal to -half. Solution, you first write sine x is equal to +half. And then find the angle x. So you know x is equal to 30 here. But this 30 sign is positive, as you can see. It is not part of the solution. The solution you're looking for is you get this 30 now, go where sign is negative in the third and fourth quadrant. In the third quadrant, you say x, since we are using x there, you say x is equal to 180 plus 30. So it will be 180 plus 30. And also 360 minus 30. So we have 210, we have 330. These two will be the solutions. So if you have the angle 30, 45, or 60, and you're looking for angles in the third, second, or fourth quadrant, you use these equations in red ink. So take note of that. And you appreciate this when you're doing equations. Okay. For you to enjoy the equations mostly move with identities. But the most basic identities that are used in equations, identities used in equations. The first one is sine squared x plus cos squared x is equal to 1. This one is very basic. The second one, remember we did this, if you divide sine squared throughout, you have 1 plus cot squared x is equal to
180 plus.
Hello?
I'm a bit confused. Is it theta is equal to 180 minus x, or it's x is equal to 180 minus theta? What's the correct equation on the quadrants?
There are two equations. If you want the reference, you use theta minus 180. If you want an angle corresponding to a reference angle, you use 180 plus x. So if you want a bigger angle, this is a small angle. Is it okay?
Yes, so same goes for the second quadrant, right? Or let me
Yes.
just say all the quadrants.
All the quadrants. Okay, then the third one, if you divide by cos, you now have tan squared x plus 1 is equal to sec squared x. You need these in equations. This is set 1. Set 2 of identity that are useful. 1 is knowing that sine A plus B is simply sine A cos B plus sine B cos A. We want this so that we're able to drive sine of 2x. How do you drive it? 2x is the same thing as x plus x. That will lead us to sine x cos x plus sine x cos x, which is always 2 sine x cos x. So sine 2x is these are the equations that these are identities that you find when dealing with equations. 1. 2. You need cos A plus B. This is cos A cos B minus sine A sine B, so that you are able to know that cos 2x, which you can write as cos x plus x, is simply cos x minus sine x sine x. So it becomes cos squared x minus sine squared x. Like that. You need this identity. These two. The third one that I've seen also in equations is tan A plus B. This is tan A plus tan B over 1 minus tan A tan B. So that we are able to use this 2x, that will be tan x plus x, which is tan x plus tan x over 1 minus tan x multiplied by tan x, which gives us 2 tan x over 1 minus tan squared x. This is very key. I've seen it in identity. So in most equations, you find these. You find this, you find this, you find this. If you don't find these three, then you find equations that requires this. If you're able to remember these, then they will take you to simple questions. Okay? We do examples now.
So,
Now,
so is there any tip for now you can know if you need to do the you need to do the bringing of the equation when you are solving for what's this for the equation? Because me, I have a problem when we are solving for x, maybe in the equation. sometimes the question might be straightforward, but me, the first thing I think of is just to bring out the identity. Is there anything you see, you used to see maybe at here, you will just do the, you don't bring out identity, something like that?
Maybe most what guides is how the question has been phrased. Let me, I'm just trying to open this. So look at this. Right. Well,
So I'm
for-
asking for the previous slide. All right, thank you.
So they say solve for 0 is equal to 360. Hello.
On the tan identity, is there a situation where they are going to say tan, then x minus x? Why you change the identity?
Tan x minus x.
Okay, thank you.
That is like tan 0.
All right,
So
thank you.
don't appreciate, okay, so solve for x between 0 and 360. If you are given sine 2x is equal to 2 tan 2x. Have you seen that? You have sine 2x is equal to 2 tan 2x. This is when you know I need some kind of identity. Okay, not much, not necessary to split sine into 2 sine, cos, and tan into that identity, but at least to change tan from being tan to being sine over cos, like that. Okay, then you cross multiply. So you have, if I cross multiply, we'll have sine 2x cos 2x is equal to 2 sine 2x. You don't divide, when you're solving equations, you don't divide the variable. So just because you have sine 2x this side and you divide, that becomes wrong. So you take this the other side so that you have sine 2x cos 2x minus 2 sine 2x is equal to 0. Factor out the common thing, that is sine 2x, and you remain with cos 2x minus 2 is equal to 0. So this means we have sine 2x is equal to 0 or cos 2x is equal to 2. But this one is not defined. Not defined. Why? Because cos runs from -1 up to 1. It can't go beyond those two numbers. Meaning, we've remained with sine 2x is equal to 0. Simple like that. Now we have a 2x inside. Should we expand to the other identity? You are free to do so if you want. Okay, if you want, you can use that identity 2 sin x cos x is 0. If you divide by 2, divide by 2, divide by 2, we'll have sin x cos x is 0. This means either sin x is 0 or cos x is 0. At which point is sin x 0? So sin x is 0 when x is 0 from the big 5. When x is 180 and when x is 360. And cos is 0 when x is 90 and when x is 270.
That very moment. So what happened is that your phone was not doing. Like what happened is that only my call was not going through when you were.
If you went to this, you say, okay, I want to say sine A is equal to 0. So I know A is going to be 0. A is going to be 180. A is going to be 360. Well, but because your angle is doubled, you can go beyond 360 and still get back to so because our x, because now we are saying A is equal to 2x. Okay, meaning for you to get x, you need to divide A by 2. So x is equal to A over 2. So then what do I do? Oh, I can go beyond 360 and when I divide by 2, I'll come back. So you get to this 180 and add 360. So A is going to be 360 plus 180, which is 540. And also A is going to be 360 plus 360, 720. Then divide by 2. Divide by 2 to get x. So we'll have that divided by 2, we get 270. If you divide 720 by 2, we'll get 360. So this one will take us back to there. So now when you got your x values, you come there and say, okay, my x values. So to this 0, if you add 360, you get 360. And then divide it by 2, you get 180 as your x. Then we come back and say, okay, since x is a over 2, 0 over 2 is 0. 180 over 2, 90. 360 over 2, 180. And then you saw 540 over 2, 270. How many angles do we have? 1, 2, 3, 4. Then we have the last one is 720 over 2, 360. We have retrieved all the angles 1, 2, 3, 4, 5. But we could get even here if we went the other way using that identity. We could still find them. So the whole idea is if you are given a positive, if sine, you get as you solve your equation, you arrive at sine is equal to positive something, you know you are checking in 2 quadrants. When it is 0, you are checking for the big 5 where sine is 0. We also have seen the zeros, not on 30, 60, and 45.
I had no phone, but to leave me, I started off, I boarded the bus 12 hours when I was leaving that.
So, well, this will be cutting soon.
When I boarded bus,
We are joining immediately to cut.
12 hours, and I was reaching home with 20 something.